Let's look at software programs. We've seen system software and we've seen application software. We know that software is a list of instructions that tells our device what to do, how to perform a task. So this software is a program. The device, we know, uses zeros and ones to perform a task. So we know our device uses this zeros and ones called a machine language to work. But we think of language, as in the language that we speak, as something very different. So how are they connected? Well, machine language is difficult for us to understand, but a computer or a device can understand easily. Whereas the English language, for example, a human language, is easier for us to understand. So we can use these human language terms and let the computer translate them into the machine language, so that the computer can then understand these words in the machine language. So we need to write something that computer understands, and we also need something that computer can change into its own machine language. So that's really our programming languages. If it's similar to our language, we can call it a high-level language. So this includes English words, for example. So we have many different types of programming languages. You may have heard of a few like C and Python and Java. And there are low-level languages that the computer understands. So machine language, the zeros and ones, and also assembly language. High-level language, more like English, more like human language, and this code is turned into the machine code. So assembly language is like machine code, but instead of just using zeros and ones, we can actually use some words. Now these words can easily be changed into the machine code, and that uses something called an assembler to do that. So the assembly language uses very basic commands like add and move and int for numbers. So the code is written, it's translated using something called an assembler. That goes into machine code, and the computer, the CPU inside the computer or the phone, can then action that code and perform a task. So code and instructions, that's turned into machine language by the language interpreter, and that's a compiler, assembler or interpreter. So we've seen the assembler. We have languages that are compiled into the machine language, and a compiler translates the whole program before running it, before executing it. Whereas other languages are interpreted. These convert and execute one code line at a time. Now, different devices will run the code, the programming code, in different ways. So, for example, language like Java is compiled into a machine that doesn't really exist, like a virtual machine, and then we can run that on whatever platform, any device we like. So that's the way of using a programming language that we can use on different types of devices and different type of operating systems. Now, over a few years, programs started off quite basic, even called basic, and these had instructions that were a bit more advanced than assembly language, and over time they've got a bit more easier for us to understand. So we started off using basic languages like BASIC and C and Fortran and COBOL, and then we progressed into slightly more advanced languages that we use for different reasons. So we can call these level of languages procedural languages. Now, assembly language can be written to write operating systems, but it is very time consuming. So people started to use language C. So if we look at examples of operating systems, we have Unix and Linux that use C, Windows and Mac use C, and also now use C++ as well. And that's the same as Android. That also uses C with C++. Even Apple operating system uses a form of C called Objective-C with C. Application software uses high-level languages like C++ and Java and Python. And C++ and Java and C++ and Java together with C hash, these are called object-oriented languages, which is a type of program that uses objects and classes. There are other programming languages, such as to do with the internet. So when you see a web page written HTML and the style is in a cascade style sheet. If you do something with a web page, it might be written with JavaScript, and different forms and actions that we can do on the internet might use something like Perl or PHP or ASP.NET. And we have other languages such as SQL used for databases, and there are many more. If we have a look at some websites which list top programming languages, we can see that JavaScript and Python are very popular, such as Java and C and C++. We have many others. And if we want to see what these languages do, we can see web development. Front end is pretty much what you can see. Back end is what you can't see. We can see JavaScript there for both. We can see the back end languages like Python and Java and PHP. Desktop applications, Java, C++, Python. Mobile, like phone development, Swift, Java, C hash. Game development, C++ and C hash. Top programming languages for phones, we again see Java, JavaScript, C hash, C++. So Python, common languages for both phones and computers. Top programming languages in 2020, we can see some similar languages like Python and JavaScript, and also some new languages. Writing software. So we know that we can have these programs, these lists of instructions, but how do we create them? Well, we can create the design of the code using something like a flowchart, and then we can write the instructions in a kind of form of English called pseudocode, and then we can use that to write in the programming language of choice. So in these programming languages we have similar concepts. So if we want to see something, we might print it to a screen. If we want to do some maths, we can use operators like plus and minus. If we want to repeat something, we can use a loop. We choose between two things, true or false, condition. If we want to enter something, put it in, we can use input. We want a list of items, called a list in Python, array in other languages, and things like objects come from real life as well. So these are concepts used in many, if not all, programming languages. You might have heard of a term called abstraction, which means it's not real, it's based on a model. So it's useful to model real world. So for example, if you wanted to see the path from one country to another, you could easily see that on a map. But the map isn't the whole world, it's just a model of the world, such as a globe. Also in programming, we might use something like a hierarchical typical chart. Now you see that for like a company, an organisational chart, but we use these type of abstractions to model things and use that inside the programming code design. Now how might you run software? Well, if you write some code and put it in a file, you make sure the file ending is consistent with the language that you use. So for example, Python files finish with .py. Now if you tell your device to run that file, it will look at that extension and say, okay, I know that's a Python file, for example. So it looks on the computer, the device, for the correct executable file, so .exe file, that can run your software, your code file. Now those instructions are then converted into machine code, which the device CPU loads and executes. So there it performs the task. So that's how we run software. We use some tools when we write programming code. So we can use an editor to create and edit code. If you want a bit more advanced, we might use something called an IDE, an Integrated Development Environment, and that is a set of helpful tools. So you might have an editor, compiler, a debugger which helps you find errors. We have development. So for example, something like Dreamweaver is very good when you want to create web pages, because you can see the code and see what the web page looks like. You might have heard of terms like libraries and modules. Well, code already exists. It may exist when you download the programming language, or you might download it from the internet, and this is kept within modules, and there may be many of them, so we can call them libraries or packages. We have different types of software. We may pay for it, or it may be free, or even open source. So free software means it's free, not paid for, but you can change it, and you can't change it and then ask for money for it. Open source software means it's generally open for development by many people, and we have examples like Firefox and VLC to show videos, for example, Linux, Blender and Python. Paid software, we're used to seeing things like Microsoft Office and Adobe Photoshop, which are proprietary software, what we buy. Now these may be general, so many people can use them, so we term that off the shelf. Or we may actually need software to be written specifically for our task, for our company, for example. When you buy software, you may purchase a license. So you may have a site license, or a license per machine or per user. So there's different types of software. Okay, thank you for watching, and if you haven't already, please subscribe.